Hey everyone, welcome back to the channel. If you're getting ready for a .NET interview, you know that nailing the fundamentals is key. When interviewing for a .NET role in 2026, recruiters expect more than just the definitions of the SOLID acronym. They are looking for how these principles interact with modern features like dependency injection, default interface methods, and unit testing. This is your chance to get ahead of the game and show your interviewer that you're not just a coder, you're a smart coder. Remember, .NET is a huge ecosystem, and covering everything in just one book is impossible. That's why we've put together a curated list of 4 essential books to give you a truly holistic view of the most common interview topics. You'll find the links to all of them in the description below. Also, with the modern development landscape, it's crucial to be prepared for more than just back-end questions. We've included links to books on Azure development and essential front-end technologies, which can significantly boost your chances of landing that dream role. So go ahead and check out those resources, and good luck with your preparation. We're about to dive into the questions, but first I want to hear from you. What's the one interview topic that always makes you nervous? Drop a comment below and let me know. And if this video helps you, hit that subscribe button and ring the bell so you don't miss our next deep dive.
Ever wondered why your code keeps breaking? Let's talk about the top 5 trending solid principles interview questions every .NET developer should know. First up, dependency inversion versus dependency injection. The difference lies in level versus implementation. DIP is a high-level principle stating that high-level modules should not depend on low-level modules. Both should depend on abstractions, interfaces. It's about the what, the goal of decoupling. DI is a design pattern and a technical implementation of DIP. It is the how, the act of actually passing a dependency like a service into a constructor or method so the class doesn't have to create it internally. Next, how do you implement the open-closed principle, OCP, using abstractions? OCP suggests that software entities should be open for extension but closed for modification. In .NET, we implement this by using interfaces or abstract classes. Instead of writing a method with a switch statement that checks for different types, which requires modification every time you add a new type, you define an interface, e.g., payment processor. You then create new classes for each payment method, credit card, PayPal. To add a new method, you simply create a new class. You never have to touch the existing tested code. Next, can you explain the Liskov substitution principle, LSP, with a real-world violation? LSP states that objects of a superclass should be replaceable with objects of its subclasses without breaking the application real-world violation. Imagine a base class bird with a fly method. If you create a subclass ostrich and have it throw a not implemented exception inside fly, you have violated LSP. The result, any code expecting a bird and calling fly and will crash when it unexpectedly receives an ostrich. A proper design would involve segregating the flying behavior into a separate interface. How does the interface segregation principle, ISP, relate to fat interfaces? ISP states that no client should be forced to depend on methods it does not use. A fat interface is an interface that has too many responsibilities, e.g. an iMachine interface with print and scan and fax. And if a simple printer class implements iMachine, it is forced to implement scan and fax even if it can't perform those actions. ISP encourages breaking that fat interface into smaller specific ones like iPrinter, iScanner, and iFax. Finally, what are the signs of an SRP? Single responsibility principle violation in a controller? In ASP.NET Core, a controller should only be responsible for orchestrating the request. Signs of an SRP violation, often called a FAT controller, include direct database access, using DB context directly inside an action method. Business logic, performing complex calculations or data transformations in the controller. Infrastructure tasks, sending emails, logging to a custom file system, or handling low-level file I/O within the action. Massive constructor injecting 10+ different services usually indicates the controller is trying to do too much. Want to master these principles? Follow for more tips.